Welcome to the class. Exactly what kind of solvents would you use if you want the reaction to proceed through the SN1 mechanism? Or what solvents would you use if you want the reaction to proceed through the SN2 mechanism? For this, let us study today solvents that are used in SN1 and SN2 reactions. But before seeing the solvents used in SN1 and SN2, let us look at what are the types of solvents that we encounter in organic chemistry. So mainly there are two types of solvents. The first is a polar solvent, and the second is a non-polar solvent. Now, as the name indicates, the polar solvent has charge separation. It has two charges in a molecule. The polar solvent molecule has two charges, a positive charge and a negative charge, and there is a charge separation in polar solvent. That is, there is a dipole. So the dipole here is not equivalent to 0. While in a non-polar solvent, there is no charge separation. There are no charges in the non-polar solvent molecule. So therefore, the dipole is always equal to 0. Let us see some examples of non-polar solvent. Look at benzene. Why should there be a charge separation? Because all are carbons. So they are of same electropositivity. So why should there be a charge separation? So the solvent of benzene, the solvent of cyclohexane, and you can see here CCl4, even though there is electron pulling, the total dipole moment here becomes 0 because one cancels the other. So CCl4 is an example of non-polar solvent. CS2 is example of a non-polar solvent. Here also the total dipole moment is 0 only because one cancels the other. CH2Cl2 is another example. All these are examples of non-polar solvent. Let us now come to polar solvent. Polar solvent, as I have said, as we said in non-polar, there is no charge separation. The total dipole is 0, right? Dipole moment is 0 because there is no charge separation. We have said some examples: benzene, cyclohexane, CCl4, CS2 and CH2Cl2, dichloromethane. Let us now study what is polar solvent. Polar solvent has charge separation. There is a dipole which is not equal to 0. Polar solvents, they are subdivided into two. That is, one is protic polar solvent, and the other one is aprotic polar solvent. Aprotic polar. What is protic polar? Protic polar, as the name suggests, proton, right? So there is H, right, which has bonding, which exhibits bonding. So there is hydrogen bonding that is seen in protic polar solvents. Hydrogen bonding. For a hydrogen to show bonding interaction, that hydrogen should be attached to electronegative atom, right? So it can be attached to O, it can be attached to N, or it can be attached to any halogen atom. So compounds that are having OH, NH and XH group, these solvents will be referred to as protic polar solvents. Let us see some examples of protic polar solvents. H2O, right? It is HOH, right? ROH, alcohol. RCOOH, right? All these are having OH groups, right? Here also there is OH group. NH3, right? HF, HCl, all these are protic polar solvents. They have H that can involve in hydrogen bond interaction because the H is attached to an electronegative atom, and now they can exhibit hydrogen bonding interactions. Protic polar solvents. Now let us look at aprotic polar solvent. Aprotic polar. aprotic polar solvents. Let us look at them. See, aprotic polar solvent means that there is no hydrogen bonding in it, no hydrogen bonding, but still it is polar, right? Still it is polar, mildly polar, mildly polar. Let us see some examples. Acetone. Acetone, okay, it is polar. Why? Because oxygen tries to withdraw electron, carbon becomes positive, but what happens is these two are alkyl pumping groups. They pump their electron and reduce the intensity of positive charge here. So there is only negative charge which is strong here. The positive charge intensity is drastically reduced by two pumping groups. So the negative charge plays a big role here. So it's just mildly polar. A mild polar ends exist in this molecule, acetone. Similar is the case of dimethyl sulfide. Right? It is also having this negative sign, but the positive sign is reduced by the two alkyl groups. They pump their electron, reduce the intensity. Here also negative plays a big role. Other examples include your NN dimethyl formamide. This is NN dimethyl formamide and NN dimethyl acetamide. All these are examples of aprotic polar solvents, right? Here also you can see that this becomes negative, this becomes positive, and this already withdraws electron, this pumps electron. The positive charge here reduces drastically, so that negative charge only plays a role here, right? It is having a negative charge which is strong and a positive charge which is not so strong. Another example is your diethyl ether, C2H5O, C2H5O, diethyl ether. So all these are examples of aprotic polar solvents. They are mildly polar, they do not exhibit any hydrogen bonding, and negative end plays a big role here. The positive charge is drastically reduced. The intensity of the positive charge is drastically reduced by the pumping groups around it. Aprotic polar. Now let us look how it plays a role in SN1 and SN2 reaction. How solvents play a role in SN1 and SN2 reaction. But before mentioning the effect of solvent, let me tell to you that the main factor that affects SN1 and SN2 reaction is the nature of the substrate. The nature of the substrate. That is, if it is a tertiary alkyl halide, it would go for SN1. If it is a primary alkyl halide, it would go for SN2. This is the main factor that decides whether the reaction would proceed through SN1 and SN2 route. The second factor that decides is nature of the nucleophile and nature of the leaving group, right? If nucleophile is strong and leaving group is weak, then it will proceed through SN2 mechanism, right? But if vice versa is the case, then SN1 mechanism. Okay, so this is the second most important factor. The third important factor is, as we are discussing today, solvent. So solvent is the lesser important than these two factors, which greatly determine whether the reaction will proceed through the SN1 or SN2 mechanism. So today we are discussing the solvent part. Now let us come to solvents. Solvents in SN1. Okay, let's discuss SN1 first. SN1, what it does, what is a prerequisite for SN1? The substrate should undergo ionization. SN1 involves the formation of carbocation, and carbocation formation proceeds only through ionization. So that is the most important step. And any solvent that promote ionization or that supports ionization, only in that solvent is most favorable for SN1 reaction. Did you get it? SN1 reaction, it involves formation of a carbocation. which proceeds through ionization. Ionization happens in SN1 only. So those solvents which support ionization, those solvents which favor ionization, in those solvents will be most suitable for SN1 reaction. Fine. Now let us see the case of protic polar solvents. Protic polar solvents. Protic polar solvents has good polarity. I have explained protic polar solvent. They show hydrogen bonding. They have OH, NH or XH groups. So they show good hydrogen bonding. So a very common example of protic polar solvent is the water. Okay, so I am going to draw water now and explain to you the solvation. This is the positive part of the substrate, that is alkyl halide, right? Let me rub this. Okay. This is protic polar solvent, and look at this, how it is making interactions with the molecule of water. All around the molecule we can see interactions with molecule of water. You can write a negative sign in water and positive sign in hydrogen, right? You can do that by a full, you can do by yourself. I hope that it is understood. Now the positive part of the substrate, that is the carbocation, is solvated well by the polar solvent. Let us look at the negative side. In the same way, the negative side is also solvated well. The H, positively charged H, it solvates the negative side of the substrate. The positive H, you can write positive. The positive H well solvates the negative part of the substrate, the leaving group, while the positive carbocation is solvated well by the negative part of the solvent. So you can see how the carbocation is solvated well. Not only is it solvated well, it is actually stabilized, right? Because the positive charge here has been attracted by so many negatively charged oxygen atoms. The intensity of this positive charge also is reduced to some extent, so it is much more stable. Carbocation formation is much more stable in protic polar solvents. Protic polar solvents. So actually ionization is favored in protic polar solvents. Ionization is favored in protic polar solvents, and therefore protic polar solvents, in protic polar solvents, SN1 reaction would take place. That is, a reaction would proceed through SN1 mechanism in protic polar solvents, because ionization is favored, the ions are solvated well. Not only that, the carbocation is stabilized by solvation by the charges, opposite charges of the solvent molecule. So that is okay with protic polar. Now let us see what would happen in aprotic polar. Aprotic polar solvent. We will see the solvation diagram. So I am going to draw acetone. So this is the acetone molecule. Now this side becomes negative, right? And this side slightly it will be positive, yeah, because somewhere this positive charge is drastically reduced. Now it will form interaction with only carbocation. The carbocation, there is actually no molecule to form interaction with X minus. This does not have a sufficient charge. The carbon here, the positively charged carbon doesn't have that much charge to make interaction with it, because its charge is drastically reduced. Positive charge is drastically reduced by the two alkyl groups by pumping of the two alkyl groups. So only the negative side here is strong in aprotic polar, and therefore it will interact only with the positive side of the substrate. Positive side of the substrate. So that won't be enough for ionization. That won't be enough for ionization. So here ionization won't take place because the solvent is not so ionizing, right? The solvent is not so ionizing. Ionization won't take place. This much energy is not sufficient. It won't be sufficient for ionization. Fine. So here SN2 mechanism would take place. Here the reaction would proceed through SN2 mechanism. Also nucleophile should be strong, provided nucleophile is strong enough. That is, the nucleophile should come and it should collide with this, right, with the substrate. If that is so, if the nucleophile is strong enough, if the nucleophile is strong enough to collide with the substrate very fast, then it will proceed through the SN2 mechanism. It will proceed through SN2 mechanism in aprotic polar solvent, where there is no, it is mildly polar, it is forming interaction only with the positive side of the substrate. Ionization is not possible because that much attraction is not being provided. So it will proceed through SN2 mechanism in the presence of strong nucleophile. Now that is for aprotic polar. Now let us come to your non-polar solvents. Look at non-polar solvent. Is there any charge in non-polar solvent like cyclohexane or benzene? Is there any charge? There is no charge at all. So it won't promote ionization in any way. It won't promote ionization in any way. Therefore, the reaction will always proceed through SN2 route only. Reaction will always proceed through SN2 route only. So we have discussed that for a reaction to proceed through the SN1 route, we would require protic polar solvent. For SN2 route, we require a non-polar solvent. And aprotic polar solvents, if we are doing the reaction in aprotic polar solvents, if there is a good nucleophile, if the nucleophile is strong enough, then the reaction would proceed through the SN2 route. There are very less chances. We can't accurately say, but there are very less chances that the reaction will go through SN1 mechanism in aprotic polar solvent. That would occur only if the nucleophile, incoming nucleophile is very weak and the leaving group is very strong. In such cases, it may occur. But in most of the cases in aprotic polar solvent, reaction will proceed only through the SN2 route. Dear students, to know more about SN1 and SN2 reaction, kindly refer to my earlier videos. If you have liked the class and if you have understood it, please do not forget to subscribe this channel. Thank you very much.